Right, good afternoon, second year. What we're going to be looking at today is we're going to be continuing our work in fractions by comparing two different fractions to see which one is bigger and which one is smaller, okay? So a lot of these examples will start off very, very easy, and a lot of them will be quite trivial, to be honest, but eventually we'll go on to harder ones that are going to have different denominators, and you're going to need to prove to me which one is the smallest, which one is the biggest, okay? So for example, what we started off at the very beginning of fractions, if you remember, this was, if I was to shade in a quarter of this, and you can clearly see this has been split up into 4 equal segments here, can't you? So it's been split up into quarters. So if I was to shade in 1/4 of that, it would just simply be one of the boxes. Similarly, if I was to shade in 3/4, for example, I would shade in 3 of the 4, okay, it's 3/4, okay? So we already know how to do that. That's actually quite easy, to be honest. What we'll start off by doing then is we're going to be looking at these 3 new properties, okay? So you might remember this from primary school, and we're going to be using our inequalities symbols to say if they're greater than, less than, or equal to, okay? So first of all, if you want to make a quick note of this symbol here, this means greater than. This symbol here means less than. And obviously we already know that that symbol there means equal to. Okay, so we're going to be using those 3 symbols here to denote which things are smaller, which ones are greater, which ones are equal to, okay? So when you go to actually make a note of this just now, you're just going to put the heading ordering fractions. Okay, this will be the first thing you copy down just now. So this one here, we've shaded 3/4 of this box just now, okay? So what we're going to do is we'll start off with a very easy example, example 1 just now. I want you to use these symbols to say which one is greater, less than, or if they're equal to each other, okay? So we'll start off very, very easy. We'll start off by saying 5/8, and to the right hand side here, we'll say 2/8 over here, okay? So when you're looking at fractions like these, I always kind of think it's a good habit to get into when you're looking at them to see which ones would actually simplify, okay? So remember, if you're simplifying fractions, you're thinking of numbers that go into either of these, okay? So this is very easy to look at these 2 things and think, right, which one is greater. So imagine you had a box here and you'd split it up into 8ths. So instead of splitting up into quarters here, imagine you split it up into 8ths. And imagine if you shade in 5 of them, 5 of the 8 compared with 2 of the 8. So obviously 5/8 would be greater than 2/8, wouldn't it? So we could simply put in our greater than symbol, which is this one here. And that's all you're going to be doing for the first few exercises, okay? So you're only looking at the number on your numerator if your denominator is the exact same, okay? So just when you're doing this, remember you've only usually seen fractions with a number in your numerator that's less than your denominator, but you could have something like this. You could even have 13/8 and 15/8. Okay, still a fraction. It's just an improper fraction, which we've not actually got to, but nothing changes. Okay, if you get 13/8 compared with 15/8, obviously the 15/8 is greater, isn't it? So 13/8 would be less than 15/8, so less than would be that symbol there. Okay, so that's all you're doing for the first few exercises. However, when you go on to look at the harder ones, okay, so example 2 here is going to be a harder one. You'll start to have different denominators, okay? So if I started off by saying 3/4 and 5/8, okay, and we're going to write down which one we think is bigger or smaller, but in maths we need to prove why it's the case. If I'm looking at something like that, it's very, very easy, and it's a very common mistake to think that number there's a 5, that number here in my other numerator is only 3, so that one must be greater than, okay? But I'll show you why that's not the case, okay? So to do this, what we need to do is we need to think of our 2 fractions and make this denominator the exact same, okay? So just underneath this just now, I'm going to think what my denominator is going to be. So this 4 here, this denominator here, I want to make these 2 denominators the same number. So which number do I know that goes into it? 4 goes into it and 8 also goes into it. So 8 would be one, wouldn't it? Because 8 goes into 8 obviously, and 4 also goes into 8. So if I compare these 2 fractions just now, 5/8 with this thing here, I've not done anything to that one, have I? So I can still keep that as 5/8. However, this 4 here, what have I multiplied 4 by to get 8? I've multiplied it by 2, haven't I? So 4 multiplied by 2 gives me the 8. Therefore, I need to multiply that number in the numerator by 2 as well to give us a 6, okay? So you can clearly see here that the 6/8 would be greater than 5/8, wouldn't it? So it's a very common mistake for people to look at two fractions like that and think that number there, my numerator's bigger than that one, so it must be greater than, but obviously that's not the case. You need to make sure that the number at the bottom is the exact same. Okay, so I'll show you another example very quickly on that. If we say we write down 2/3 and we write down 7/9, okay, and we're going to write down which one we think's greater than. Okay, so obviously we can't just look at these just now and think, right, what one is greater than? We need to make the denominator the exact same. So write in my empty fractions again. So I'm trying to think, what would my denominator be here this time? So which number do I know that 3 goes into it and also 9 goes into it? So you could think of numbers like 27 and things like that, but that just becomes a wee bit harder. We need to change both of them. I'm thinking 9. You can make both of these denominators 9 because 9 obviously goes into 9 and 3 goes into 9. So again, I'm just going to start off with this one here because it's easier. I've not done anything to this one, have I? 9's just stayed as 9. So that number there in the numerator can stay as 7. What have I multiplied 3 by to get 9? Multiplied it by 3, so which means I need to do the same to my denominator, to my numerator here. So 2 multiplied by 3 is 6. So I've got 6/9 and 7/9. So which one is greater? Obviously the 7/9 is greater than, isn't it? So 6/9 is less than. So this symbol here is less than 7/9. So if you get two denominators like this that are different to each other, you need to start off by changing them into the same denominator at the bottom. So you'll notice that this one here, I didn't change this one here, just kept it at 7/9, whereas this one here at 2/3, I had to change into 6/9. So easily I can tell which one's greater than, which one's less than. Okay, so that will let you do the last page